Hello today, guys. This video is going to cover section 6-4, and it's going to be more of a continuation from lesson 6-3. So we're going to be making more comparative inferences about populations. Now today we're going to be looking more at dot plots. In section 6-3, we looked a lot at box and whisker plots. So dot plots, here we go. Example 1, we're going to be using dot plots to compare populations. We'll be looking at two sets of data that are in a dot plot. We're going to do the same thing we did in section 6-3. We're going to compare them. We're going to look at medians, the interquartile ranges, the spread of the data, all that fun stuff. So this question says, Quinn collects data from a random sample of 20 7th grade students who participate in a youth fitness program. She compares the number of curl-ups each student completed in 30 seconds, last year and this year. What can Quinn infer from her comparison of the data sets? So in this green, okay, we've got the number of sit-ups, or curl-ups rather, that students did last year. And this year, we have the same sort of recording, but how many curl-ups they could do this year. Now these are 20 students, and all we're going to be doing is comparing last year to this year. So we're going to display these on a dot plot. So what that means, we have a number line, and each one of these dots goes with a number on here. So 20 here, 20 there, 21 here, 21 here, etc. So each one of these numbers goes with these. So if there's 20 numbers here, there's going to be 20 dots here, vice versa. So one of the reasons I like looking at dot plots is because we can kind of see a curve, right? So we've displayed all the data on these two dot plots going from 20 to 30, 20 to 30. Now step 2, we're going to use the dot plot to compare the two data sets. So big word, compare the two data sets. So when we look at this first dot plot here on top, this is last year's. Now, what we have here in this little arrow, the mode. Now, what you should know is that the mode stands for the most occurring number. So obviously, I can look at this and say, well, the number here that has the most dots is 24. So that means the most common number of curl-ups that students completed was 24. And here we see 5 dots, so 5 students completed 24 curl-ups. Now down here it says the range is 7. Now we should know the range is the difference between the highest and the lowest. So this goes all the way from 20 to 27. And how do you get 7? Well, we just take 27 and we minus 20. And that's how we get a range of 7. So you just subtract the biggest from the smallest, and let me rephrase that. You take the smallest, subtract it from the biggest, and you get your range. Now we look at this second graph here, right below it. We look at the same thing. Well, the mode this time is 28. We got 4 dots at 28. And then it says the range is 9. Same thing, 30, 20. So we find our range by taking 30, and we subtract 21, and we get 9. Okay. Now, when we look at these things, right off the bat, what I would notice is that this year's mode is greater than last year's mode. Okay. Now, we can also say that when you look at the range, this year's is more spread out. It goes from 20 to 30, where last year's was 20 to 27. Now, the second thing I'll have you look at are these curves. So we've got a curve that kind of looks like this. And we have a curve that kind of looks like this. Now, look where the peaks are. The peak for this year is at 28, where the peak for last year is at 24. So what can we say where we compare this year to last year, or vice versa? I think as you're looking at this, it should be fairly obvious. So the most obvious inference we can make is the number of curl-ups completed this year is generally greater than last year, right? There are more higher numbers here than there are higher numbers here. We got 2 30s, we got 3 29s, we've got 4 28s. We didn't have any 30s, 29s, or 28s last year. Okay, but based on the shape of the data, not all students made progress, because some still had 21, 22s, right? Not everyone made progress, okay, because we still have a little long tail here. So something else we can say is this. Quinn can infer, now here's our inference, that most of her classmates were able to do more curl-ups, because most of the numbers are greater than most of these, right? If I just look at this set right here, I'm going to circle these using let's use a blue circle. I got a lot from 25 to 30. When I look here, well, I only have these numbers from 25 to 30. Look how much bigger, many more data points are here than there. So most students made progress. So, vocab. The mode is a data point that occurs most often. So mode, let me use yellow there. Mode is most often. Okay, you should know that, I feel like. Okay, so in the problem above, the number that occurred the most last year is 24, and this year was 28. So those are the modes. Both of these numbers obviously represent the mode, like we talked about. Next, the range is the difference between the biggest and the smallest number. So range, difference between biggest and smallest. Got to subtract. The greater the range, now this is from section 6-3, the greater the range, the greater the variability, the more spread out the data is. So if we look here, it's more spread out in this year than it was last year. So mode, most often occurring, range, difference between biggest and smallest, and the greater the range means greater the variability. Next up. So we're going to use measures of center, and we kind of talked about this in section 6-3. We didn't really get into it. Today we're going to talk more about what a measure of center is, okay, and the variability to complete or to compare populations. So it says Quinn computes the mean. Now we should know the mean stands for average. And here's a really big word, the mean absolute deviation. I'll explain what that is in a second for each data set. How do these measures support Quinn's inference from the data displays? So what we need to know is that the mean absolute deviation, or MAD, stands for how far away each data point is from the mean. So let's say, for instance, let's look at this graph. So the curl-ups completed last year, the mean, or the average amount completed, was 23.6. So the students completed, on average, 23.6 curl-ups. Now, what this MAD number stands for, that basically said each other student was on average 1.4 curl-ups away from that mean, that average. Now that's a really confusing thing to find, and we're not going to spend so much time finding the MAD, but what we need to know is the mean absolute deviation stands for how far away someone is from the average. So if the average is 23.6, each person was on average 1.4 curl-ups away from that mean. So we look at the mean from this year's 26.6, obviously it's greater. Right, and that was indicative from our little curves that we drew. And people were 2.1 away from that mean. So how do these measures support Quinn's inference, right? We want to make sure it's valid, so we use data to support that. So the first thing we can say, the mean number of curl-ups, or average, completed this year is greater than the mean curl-ups completed last year, right? 26 is greater than 23. So this supports Quinn's inference. And easiest way to find the mean is to look at our graph. Look where the peak is here. That generally is going to tell you kind of where the mean is. Okay. Now the next thing we can say, the mean absolute deviation is greater for the number of curl-ups completed this year. Right? It was 2.1. This suggests that not all students made the same progress. So one of the things the mean absolute deviation is connected to is the variability, how spread out the data is. The more spread out the data, like it is here, the more spread out the data is, the greater the mean absolute deviation, right? The more tightly packed the data is, the lower the mean absolute deviation is. So that's kind of one of the things to see. The more spread out, the greater the MAD. The more narrow, the less the MAD is, okay? So a couple vocab words that we need to know. The mean, median, or middle in the mode are all called measures of center, right? The mean is the middle. The mean is the average. The median is the middle. The mode is the most occurring. Those things are often referred to as measures of center because they help tell us where the center of the data is, tell us where the middle is at, okay? And what I have here, they help identify the central position of the data, okay? These measures can be skewed, however. So if we think back to section 6-3, we think of outliers, okay? Those outliers, they affect these measures of center. So we look at up here in this graph, this 20, this 21, and these 22, they're outliers. They don't really fall in the middle of this pack like the rest of them did, okay, they can affect the mean or the median, and they can make for a higher mean absolute deviation. So these outliers are numbers in a data set that aren't representative of the overall data. That's what outliers are. They throw off our data. They throw off the numbers. Okay, if we think of it in terms of, say, basketball, let's say, for instance, we pick a player like Giannis Antetokounmpo, right? I know I'm not saying that right, but let's go with it. So let's say Giannis averages 25 points per game, but let's say one game he got hurt and only averaged 5. So that 5 points is going to throw off his overall scoring. So we're not really going to look at that number. That's not indicative of how many points he scores per game. So that's an outlier. Okay, outliers are bad for data. We try to throw them away and we don't really count them. So last example, example 3. Use statistical measures to make predictions. So how can we use data to make predictions? So it says Rafi, one of Quinn's classmates, reported the numbers of curl-ups he completed this year and last year. He did not tell Quinn which number is for each year. So one number was 19 curl-ups, the other number was 23. So based on our data, these charts above, which number probably goes with last year and which number goes with this year? So what I can see is that the numbers from last year were lower than numbers from this year. So that would make me think that this 19 is from last year, and we're going to make the assumption that he improved. So now this number is this year. And that's going to be the same thing Quinn is going to say. Based on the data that Quinn gathered, she inferred that most students would complete more curl-ups. Okay? So they went up. Okay? So what we can say is, so Rafi most likely completed 19 curl-ups last year and then 23 curl-ups this year. That's just, we're using a model. We see that more people completed it this year than last year. So we're going to say the lower numbers last year, the bigger number is this year. So in review, you can use dot plots to make informal comparative inferences about two populations. We can compare shapes of data, so like these little curves that we make. Okay. We can use measures of center, mean, median, and mode, and variability, how spread out it is. All right, so here's two data sets, right? We got this data set here. We have this data set here. Okay, so a couple of things we can say is that the modes for data set B are greater, right? So here are two modes here for A, and the two modes for B are here. The mode for data set B are greater. Okay, we look at the means, right? The average of both. Mean for A is here. Mean for B is there. 18 is better than 15. So B is greater. Okay, we're just comparing. Now if we look at the mean absolute deviation, that tells us about how spread. Okay. Look at how tight all of this is in here. Okay. However, what could throw something like this off? Look at these two little guys right over here. We would call those outliers. So what they're going to do is they're going to make the mean absolute deviation a little bit bigger. Okay, because they're not as packed. These are kind of more tightly all wound up together. Okay, that's why it's just a little bit lower. Okay, now they are pretty similar. 1.9 is very similar to 2.1. So we can say that the variability is about the same. Okay, so going back, mean, median, and mode. Mean is average, mode is most occurring, median is the middle. Mean absolute deviation, how far is something away from the mean? Okay, how spread out the data? The more spread out, the greater the MAD. The tighter it is packed in, the lower the MAD. Okay, so still we're just comparing two sets of data, looking at the numbers, looking at the dots.